Let's review what happens during a physical change. In previous chapters, you've studied different aspects of physical change. When atoms and molecules speed up or slow down, that is a physical change. When they change state from liquid to solid or from gas to liquid, that's a physical change. When a substance is dissolved. In previous classes, you studied different aspects of physical change. When atoms and molecules speed up or slow down, that's a physical change. When they change state from liquid to solid or from gas to liquid, that's also a physical change. When a substance is dissolved by water or some other solvent, a new substance has not really been formed. The ions or molecules can still come back together to form the original substance. So that's also a physical change. So if we know what a physical change is, what happens during a chemical change? The atoms in the reactants rearrange themselves and bond together differently to form one or more new products with different characteristics than the reactants. When a new substance is formed, the change is called a chemical change. In this lesson, we're going to explore what happens during these chemical changes. In most chemical reactions, two or more substances called reactants interact to create different substances called products. Burning a candle is an example of a chemical reaction. What do you think are the reactants in this chemical reaction? It's true that the string of the wick does burn, but it's the wax on the string and not so much the string itself that burns and keeps the candle burning. The molecules that make up the wax combine with oxygen from the air to make the products, carbon dioxide and water vapor. This is one of the major characteristics of a chemical reaction. In a chemical reaction, atoms in the reactants combine in new and different ways to form the molecules of the products. You may be surprised that water can be produced from combustion or burning. It is also interesting to know that when you burn food in your bodies, you also produce carbon dioxide and water. Now remember, air is a mixture of gases. When something burns, it reacts with the oxygen in the air. Will the candle still burn if one of the reactants, wax or oxygen, is no longer available? Why do you think the flame goes out when we put a jar over a candle? Placing a jar over the candle limits the amount of oxygen in the air around the candle. Without enough oxygen to react with the wax, the chemical reaction cannot take place, and the candle cannot burn. When a candle burns, the candle wax seems to disappear. It doesn't really disappear, though. It reacts chemically, and the new products go into the air. This is the chemical equation for the combustion of methane. The atoms rearrange to become different molecules. Wax is made of long molecules called paraffin, and that paraffin is made up of only carbon atoms and hydrogen atoms bonded together. Molecules made of only carbon and hydrogen are called hydrocarbons. We will use the simple hydrocarbon, methane, as a model to show how the wax or any other hydrocarbon burns. Here is the chemical equation again. The molecules on the left side are the reactants, and the ones on the right side are the products. When the candle was burning, the paraffin reacted with oxygen in the air to produce carbon dioxide and water, similar to the chemical reaction between methane and oxygen. The chemical formula for methane is CH4. This means that methane is made up of one carbon atom and 4 hydrogen atoms. The other reactant is 2 molecules of oxygen gas. Each molecule of oxygen gas is made up of 2 oxygen atoms bonded together. When we talk about the oxygen in the air, it is always the molecule of oxygen, which is 2 oxygen atoms bonded together, or O2. Where do the atoms come from that make the carbon dioxide and the water on the right side of the equation? Well, the atoms in the products come from the atoms in the reactants. In a chemical reaction, bonds between atoms in the reactants are broken, and the atoms rearrange and form new bonds to make the products.